Alright, on this lesson we're talking about the triangle exterior angle theorem. Angle 1 would be an exterior angle. Since one of the sides, in this case the bottom side, has been extended with a ray, that forms an angle with this side of the triangle, so that's what we consider to be an exterior angle. Angles 2 and 3 would be known as the remote interior angles. This angle right beside 1 would also be an interior angle, and it would be an adjacent interior angle. The rule about exterior angles is that they will always equal the sum of the remote interior angles. So in this case, the measure of angle 1 equals the measures of angles 2 and 3 added together. Now, setting that up on our first problem here, what you're going to see is, by the way, this is example 2. Example 1 was proving that theorem, so I can go over that with you where we can actually have a conversation about the proof. But on the video, just breaking down how to do the problems. Angle 1 is an exterior angle because one of the sides has been extended and it's outside the triangle. As far as what it would equal the sum of 40 and 30, since those are the remote interior angles. So in this case, the measure of angle 1 is equal to 70, and I'd be done with the problem. Now, an alternative approach here would be I could find this interior angle by taking 40 and 30 away from 180. So if I did 180, because they are interior angles of a triangle, if I did 180 minus 40 minus 30, I'd find 110 degrees for that angle. Then I could take that 110 away from 180 and get 70 for angle 1, since these are supplementary angles. So that's another way to approach the problem, but I'm focusing today on using the theorem where we just take the 180 degrees out of that, and that's really leading to what the proof was that we covered in class. Now in this next problem, the 113 degrees is the exterior angle. So 113 degrees equals the sum of the remote interior angles, which are 70 and angle 2. So 70 plus the measure of angle 2. Now what I have to do on this problem is actually subtract 70 to finish it off, and I get 43 for my angle. Now I did go over a few of the problems that were on the assignment in class, so that's what I'm doing here. For instance, on number 15, very complicated looking diagram, I'm supposed to be finding this missing angle measure. There's not enough on this triangle to do that yet, so that's the reason why I actually have to start over here and do a little bit of work to find out this angle that's on the interior, then I can figure it out. So starting off, I'd actually write 45 degrees in right here using vertical angles. Then I'd be able to find this interior angle by subtracting 45 and 60 away from 180. So 180, because the interior angles of a triangle always add to 180 degrees, subtract 60, subtract 45. And I end up getting 75 degrees for this interior angle right there. Now what I would do is actually consider these three angles together form a line which is 180 degrees. And I will subtract away 75 and 68 from 180 to be able to get this interior angle. So 180 degrees for the line, that is, subtract 68, subtract 75. And then it ends up being 37 degrees for that interior angle. Now, how to wrap this problem up. You could find this angle, but if I'm looking for the exterior angle here, I'm going to apply the theorem I was just learning. This exterior angle will equal your two remote interior angles added together. 100 plus 37 is 137 for my final answer. Now I did also go over number 23, and then I also set up number 24. So on number 23, what's going to happen here is I would move the 8x plus 4 into the triangle using vertical angles. Now I would know that the 130 is an exterior angle, so it's going to equal the sum of the remote interior angles, which are 3x minus 6 and 8x plus 4. So my setup here is 3x minus 6 plus 8x plus 4 equals 130 degrees, the exterior angle. Now I'm ready to go ahead and solve the equation. So I'd have 11x minus 2 equals 130. Add the 2 over, I'd have 11x equals 132. And when I divide by 11, 132 divided by 11 is 12. Now that I've got x, this is actually not the answer. The instructions, which you can't see here, were to actually find the measure of angle A. So since the measure of angle A is equal to 3x minus 6 on this problem, I'm going to plug in the 12 for x. 3 times 12 minus 6. 3 times 12 is 36. 36 minus 6 is 30 degrees is my final answer here. So if the problem says find the value of the variable, you would have actually stopped here. But on this problem, it did say find the value of measure of angle A, which is the reason why I plugged it back in. Alright, last thing I'm going to talk about in this video is number 24, the setup. So I'd use vertical angles again, so 4x plus 17 can be written in here. And now these are interior angles. This is not involving exterior angles. So remember, with interior angles, you add them to 180 degrees. So the 4x plus 17, which is now an interior angle, plus the x plus 23, plus the 80 degrees, has to equal 180 degrees. So now you just got to solve this equation for x by combining like terms. I will include that step. That was combining 4x with x to make 5x, and 17 plus 23 plus 80 made 120. Solve that for x, and then plug it back in for angle A to know what its value is. Alright, that wraps up my lesson on exterior angles. Please let me know what questions you have. Thank you.